Okay, so you are going to start this by doing a warm-up. So I want you to notice that on this first question, you are not actually solving it. I just want you to think about what is the strategy, okay? You know, we have two shapes here. We have the volume of a hexagonal prism, and we have the volume of a cylinder. What do you do with those two shapes to find the volume of the solid that we have a picture of? So, because the hexagonal prism is on the outside, that would be the complete volume if there wasn't this hole cut through it. But because we have this hole that's in the shape of a cylinder, we have to take that volume of a cylinder and we have to remove it because that's not part of the volume of this solid right here. Okay? Now I also want you to give this practice SAT question a try. So when we give this a try, we're looking to do the volume of a cylinder, which we know is going to be the area of the base times the height. So in this case, it says that we have a cylinder. The circle has a diameter of 10, which means our radius is 5. And it says its height is equal to the radius. So this distance right here is also 5. So my area of my base is the area of the circle, so pi times the radius squared. That's the area of my base. And I'm going to multiply it by my height, which is also 5. And that gives me 125 pi inches cubed. All right, so we are going to take a look at a video. And while you watch the video, I just want you to consider what this tells us about the formula of a pyramid. So notice we have this pyramid that was sitting on top of the prism, and the pyramid and the prism, they have the same base, and I want you to notice that they also have the same height. So the only difference between these, they have the same base, they have the same height. The only difference is one comes to a point, because it's a pyramid, and the other is a prism. So the first thing I'd ask you is the volume of the pyramid the same as the volume of the prism? So the volume of the prism and the volume of the pyramid were not the same. What is the relationship between the volume of the pyramid and the volume of the prism? How many pyramids fit into the prism? So, when you think about this, oh, I have a fun loading situation here. All right, so when we think about the volume of the prism, that's the one you already know, right? Where all the two bases are parallel to each other. We know that area to be the area, that volume to be the area of the base times the height. So the question now is, how did that volume of a pyramid relate to that? We said that it's not equal to the area of the base times the height, because 3 of the pyramids fit into the prism, right? So that means if we took the volume of a prism and divided it into 3, we would be able to calculate the volume of the pyramid. And this is also true for your volume of a cone. So we're going to give this one a try. Now don't forget, a pyramid is going to have a pointed top, okay? So a pyramid, I'm spelling this wrong, pyramid, is going to have some shape that is the base, and then every vertex of that base connects at a point. So don't forget that that's the difference between the pyramid and the prism. Okay, so we're going to give this a try. So we know that the volume is going to be the area of the base times the height. So let's think about these. This tells us that the cone, now what is a cone? A cone is like a pyramid, except it's different because it doesn't have a polygon base. So our cone looks something like this, right? A circle that comes up to a point. With a base diameter of 10 inches, so that means our radius is 5, and a slant height of 13. So that means this 13 is that side that's on a slant here. So when trying to fill out this formula, we can find the area of a base. The base is the circle, right? So that's going to be pi times the radius squared. So we get 25 pi as the area of our base. And now we need to know the height of the cone. But remember, one thing we know is that the height is always talking, when it just says height, we're always talking about this perpendicular height, okay? So that slant height of 13 is not the height that we're trying to find. But what I can do is when I draw that height in, that altitude from the top to the center of the base, one thing I notice is because it's a perpendicular height, I have a right triangle right here. And we see that we have 5 and 13. We see that this is a triple, a 5, 12, 13. So my height is going to be 12. So now I can go back to my equation. My area of my base is 25 pi. My height is 12. And therefore, I get 25, and divided by 3, of course. So 25 times 12 divided by 3, which gives us 100 pi. And I make sure I don't forget my units. That's going to be inches cubed for my volume. So when we are given a slant height, it's very important that we always look for right triangles to find the height. Okay, so let's take a look at this example. So we're finding the volume of a square pyramid, okay, that has a base edge of 10. So when it says square pyramid, that means that this base right here is a square. So all my sides, my base edges, they are all 10, okay? And it tells me that I have a slant height of 13. Okay, so I could draw that a couple different places. The slant height could be drawn from the point or the apex to the middle of any of our faces. So let's say I draw it here. That slant height is what we're talking about when we say slant height is 13. So this is 13 right here. Okay, so that goes, notice that's not a lateral edge, right? That is different. So this is going from the apex to the center of the base of one of the faces, right? So where can I get a right triangle? Well, if I drop an altitude to the center of the base, okay, and it's perpendicular, then I have a right triangle right here. Okay, now one thing I notice here is I have to figure out what is this distance right here. Well, if it's going from the center directly to the edge of the base, right? If it's directly in the center, then that's half of this distance, 10. So it's 5. Oh, look at that. We have another 5, 12, 13 triangle. So that allows us to find that the height is 12. That height, it always has to be perpendicular. And then the area of the base, it's a square base, it says, right? So that's side squared, or base times height, which is 10 squared, which is going to be 100. So when I find my volume, it's the area of the base, which is 100, times the height, which is 12, divided by 3. So 100 times 12 divided by 3 gives us a volume of 400. Now I can't forget my units, but they didn't tell me any type of unit, so I'm just going to put units squared. Okay, let's take a look at another example. So this tells us that we're thinking about another square pyramid, right? So here's my base, it's a square, okay, because it says that it's square pyramid. And it has a base edge of 18, okay? And then it also tells us that we have a lateral edge. Now remember, a lateral edge is different than the slant height. The lateral edge is going to be one of these segments that's connecting the vertex to the apex, okay? And the lateral edge is 15, okay? So we want to find the area, or the volume. Again, the volume is going to be the area of the base times the height divided by 3. So finding the area of the base, no problem. If it's a square, it's going to be 18 squared, which is going to be 324. So that's the area of my base. But again, it's the height that's the problem. Right now, what we've drawn in is not the height, right? Because it is the lateral edge, okay? So we're going to take a look at this. So we need to think about a few things. We need to think about specifically a couple different triangles, really, okay? So when I take a look at this, one triangle I could draw in is with the slant height like we did before. Okay, so maybe I should move my 15. I don't know. I'll leave it there. My 15 is the hypotenuse of that triangle, right? Okay. Do I know any other information about that triangle? Well, I do know that this would be half the side of the square. So this would have to be half of 18, which is 9. So one thing I might notice is, oh, okay, well, 9 something 15, that's actually a triple, right? It's the 3, 4, 5 triple, but multiplied by 3. So that makes the slant height 12. Okay? So now we can finish solving this problem exactly like we did with the last problem. So sometimes when I start to draw multiple triangles, on a diagram, I like to copy my drawing over and then erase that triangle so I can start a fresh drawing. So we just did this where we had the 9 on each side. We knew the the lateral edge was 15, and that allowed us to find that the slant height was 12. And now I'm going to go ahead and erase that because I don't want my drawing to get too confusing. The only one I actually still would like to keep is this slant height of 12. So I know the slant height is 12. I am now going to drop my altitude to the center, right? And now I again have that same right triangle we were talking about in the last problem. Do I know what half of the side length is? Again, that's still 9. So now we have 9, 12, and 15, right? Oh, is that right? 9, 12, 15? Oh, it's not right. You want to know why? Because if it was 9, 12, 15, then 15 would have to be the hypotenuse. But in this case, 12 is the hypotenuse, right? We always have to keep track of where that hypotenuse is. So this one doesn't actually have a triple. So I'm going to have to do a squared plus 9 squared equals the hypotenuse squared. So a squared plus 9 squared equals 12 squared. So I need to figure out what that height is. So a squared plus 81 equals 144. I'm going to subtract the 81. So now I get that the a squared is 63. And so if I square root both sides, I am going to get the a to be 3 root 7. Because this asks me for exact, I want to make sure I'm keeping it in reduced radical form, not as a decimal. So now I know that this height is 3 root 7. Okay. And now I can finish my problem. So volume is going to be the area of the base, which is 324, times the height that we found, which is 3 root 7, all divided by 3. And when I do that, I get 324 root 7, right? These 3's, they're both outside the root, so they can reduce. And then I need a unit, so that is meters cubed. All right, we have one last question to take a look at. So in this question, we're given a pentagonal pyramid, okay? And so it says each base edge is 8. I'm going to draw that there. And the altitude of the pyramid is 12. So I can actually draw this altitude straight in, and that's 12. So when I'm thinking about my volume formula, I have the area of the base times the height. I already know the height because they gave it to me, divided by 3. Okay, so I have this set up. So really, I just have to find the area of the base. Now, what I like to do when we're doing like a pentagonal or a hexagonal pyramid, I like to draw that shape, and I drew it a little too small, so I'm going to draw it a little bigger, of the base, so that when I'm trying to figure out that area, it's not as bad drawing-wise. So when we find the area of a pentagon, remember that we're thinking about this strategy, right? We know that the whole edge is 8, which means that each of these is 4. And that's all we know. So we're going to take 360. We're going to divide it into the 5 isosceles triangles. And when I do that, I get that each of the triangle has 72, right? But we're dividing that triangle into half again. So that tells us we have 36 and 36. So now I can use trig to set up to find my apothem, right? Because the area of a pentagon is going to be perimeter times apothem divided by 2. Okay, so my perimeter, we already know, is going to be 8 times 5, right? Because there's the length of the side is 8. There are 5 sides. So we have 40 for our perimeter. We still need to know our apothem. So I'm going to set up some trig. Opposite 36 is 4. Adjacent is the apothem that we want to find. So I can say that tangent of 36 equals the opposite side, which is 4, over the adjacent side, which is the apothem, right? Tangent is opposite over adjacent. Okay, and then I'm going to have to solve by multiplying by the apothem and then dividing. 4 divided by tangent of 36. So if I do that, 4 divided by tangent of 36, I get 5.5055 ... right? I want to keep as many decimals as I can until I'm actually to the end. So I'm going to put that 5.5055 into my equation for the pentagon. And when I multiply by 40 and divide by 2, I get my area of the pentagon to be 110.1105. So now I can go back to this volume formula and say 110.1105 times 12 divided by 3. And I'm going to get the volume to be 440. And now I can round to the nearest tenth. So 440.4. And my units is going to be meters cubed. Okay, that's all for today. Just as a hint, tomorrow you are definitely going to see a problem just like this, so you may want to keep these notes somewhere handy or re-reference this video. And you are also definitely going to see a question just like this, so again, keep these notes handy. You might use them, okay?